Hello everyone, welcome to this video lesson on 10-6. We're talking about secants, tangents, and angle measures today. This is going to be one lesson where we're going to use 2 pages of our circle book. So on the first page, here's the first part I want you to have written down. We'll title it right down here, 10-6, secants, tangents, and angle measures. And then in this top left-hand third or so, I want you to write down what a secant line is. So we have a tangent line. We've already been introduced to that before. A tangent line touches a circle at one and only one point, and that point is called the point of tangency. Now we're also defining what a secant line is. A secant line is a line that hits the circle in 2 different points. Okay? So there's our secant. Tangent touches it in one spot. Secant touches the circle at 2 points. When we have 2 secants that intersect inside a circle or 2 chords that intersect in a circle, the angle, we've had a central angle and we've had an inscribed angle. Now this angle 1, it's neither at the center of the circle nor is it on the circle. It's at a different spot. Here's how we can find the measure of angle 1. It's the measure of its intercepted arc. So AD, you can see this is the measure of arc AD, plus measure of arc BC. So what I consider this as is the vertical angle, its intercepted arc. So the angle that we want to know, it equals the intercepted arc plus its vertical angle's intercepted arc. We add those 2 together and divide it by 2. And that gives us the measure of the angle that we want. So we want to find an interior angle when 2 chords intersect. We add up its intercepted arc plus the vertical angle's intercepted arc and cut that in half or divide it by 2. There's our second part of our circle book. And the third part of our circle book on this page is when we have a secant and a tangent that intersects at the point of tangency. Very similar property to this one, I guess. The angle 1 here, equals its intercepted arc divided by 2. So if I want to find angle 1, I would want to know its intercepted arc, which is arc BAC. Whatever that degree measure is, I'm going to divide it by 2 to get the angle. Same thing with angle 2. To find angle 2, I would want to know its intercepted arc. Whatever its intercepted arc is, I would just divide that by 2. And that's what we get here. Okay? And notice 1 and 2, they do form a linear pair. So whatever angle 1 is and whatever angle 2 is, they should add up to equal 180 degrees. Now you can flip over the circle book, and we're going to have 10-6 continued, and we're going to have a few more properties that we're going to talk about. When 2 secants intersect outside of the circle, such as E, it's outside of the circle, well, the angle E right here, it equals arc BD, so here's arc BD, minus arc AC divided by 2. So what we're going to really have on this whole circle class is it's going to be big arc minus the small arc, and then we're going to divide that by 2. And that's how we get the angle when the angle is outside the circle. So here's the big arc BD minus the small arc AC divided by 2. That's when 2 secants intersect outside the circle. And we're going to find the same thing for the next one. When a secant and a tangent intersect outside the circle, it's the same formula. It is BED, which is the big arc, minus AD, the small arc, divided by 2. So again, this same thing exists. Big arc minus small arc divided by 2. And our third and last property on this page is when we have 2 secants. When we have 2 tangents that intersect outside the circle, the same formula remains true. It is big arc minus the small arc divided by 2. So whenever we have 2 secants, 1 secant, 1 tangent, or 2 tangents, where their intersection is a point outside that circle, that vertex of where those 2 intersect is a formula, and it's big arc minus small arc divided by 2. Very big concept in this unit. All right, you can put your circle book away. You just did a bunch of writing. Now you can take out your notes packet, and we want to find a couple different example problems. So here's the first one. We want to find the measure of angle 1, and we want to find the measure of angle 2. Well, when two chords intersect inside a circle, angle 1 is not a central angle, so it's not 88. Angle 1 is not an inscribed angle, so it's not half of 88, making it 44. It's some other relationship. So here's where we have angle 1 is equal to its intercepted arc, 88, plus the vertical angle's intercepted arc, which is 76, divided by 2. Okay, that's one of the first properties we talked about in the video lesson today. So angle 1 equals 88 plus 76 divided by 2. That's 164 divided by 2. And 164 divided by 2 is 82. 82 degrees is angle 1, 82 degrees. And angle 2 has to be supplementary because it forms a linear pair. So if we take 180 and subtract 82, we get 98 degrees. So angle 2 has to be 98 degrees. Taking a look at our next one, find the measurements of angle 1 and angle 2 again. So angle 1, when we have a secant and a tangent intersect at the point of tangency, it's equal to its intercepted arc divided by 2. So what is the degrees of angle 1's intercepted arc? Well, if we take 142 and add 92, we would get 234 degrees. And so if 234 degrees is its intercepted arc, angle 1 equals 234 divided by 2. It's half of the measure of its intercepted arc. So angle 1, 234 divided by 2 is 117 degrees. Now in a circle, there's 360 degrees. So all of this together is 360. So if I just want the measure of arc BC, it would be 360 minus the blue arc, which was 234. So arc BC, that would be 126. This arc is 126 degrees. So the measure of angle 2 is going to be half of its intercepted arc. So 126 divided by 2 is going to be 63 degrees. 63 degrees. And remember what I said earlier, aren't angle 1 and angle 2 supplementary? Because don't they form a linear pair? What do you get when you take 117 plus 63? You get 180 degrees, right? Which is how it should work out because they are supplementary. All right, on this one, here we have two secants intersecting outside of the circle. So when two secants intersect outside the circle, this is the big arc minus the small arc divided by 2 formula. So the angle, 62, that equals the big arc, 141 degrees, minus the small arc, x degrees, divided by 2. So now we're just going to use algebra and we're going to solve for x, which is the measure of the small arc. Let's multiply both sides by 2. 62 times 2 is 124. So 124 equals 141 minus x. Subtract 141 from both sides. And we get a negative 17 equals a negative x. So divide both sides by a negative 1, and x equals 17. That small arc is 17 degrees. X is 17 degrees. Okay, and our last one for today. This one we have two tangents that are intersecting outside the circle. Same formula. We have the angle equals the big arc minus the small arc divided by 2. Okay, so all we're given is the measure of the angle. So if that's all we're given, I'm just going to erase this here for a moment, but we know it's big arc minus small arc divided by 2. We want to find the measure of arc AB. So arc AB is this red arc right here. I'm just going to call that x. Question for you, how many degrees is this green arc? Well, the red and the green arc together make 360 degrees, right? So if all I want is the green arc, it's 360 degrees minus the red arc. So it'd be 360 degrees minus x. If AB is 20 degrees, then the major arc, the green arc, would be 360 minus 20, be 340. So that's kind of what we're dealing with here. So now I have enough information where I can solve for x. I can say that the angle 40 equals the big arc, 360 minus x, minus the small arc, which is x, divided by 2. Big arc minus small arc divided by 2 gives us the measure of the angle. All right, let's use algebra and let's solve this sucker. Multiply both sides by 2 again. So now I get 80. That equals 360. And a negative x minus another x is a negative 2x. I'm now going to subtract 360 to get my constants together. So if you take 80 and you subtract 360, you get a negative 280. That equals a negative 2x. And finally, divide both sides by a negative 2, and I get what x equals. Negative 280 divided by a negative 2 is 140 degrees. So I know that my minor arc is 140 degrees. So now if I want to, I could find my major arc, my big arc, by taking 360 minus 140 degrees. That concludes our lesson for today. If you have any troubles with this lesson, be sure to come to me tomorrow in class and ask me about those.